Everyone, welcome to Bratati Science Class. I am Bratati and today let's have a tour to gravitation. Okay, that is class 9 science chapter number 9. Today we are moving to gravitation. In this universe, do you think that we are attracting each other? Yes, we are. Whether it's a human being, whether it's any object, even my two hands are attracting each other. So this is the force of attraction, and that happens not only to living body, even to the non-living bodies as well. As a human being, we you know that there are many organ systems like circulatory system, excretory systems, respiratory system, and all. And so a magnetic field is acting on us. So today's topic is gravitation. You know Sir Isaac Newton, who was just reading a book in an apple garden, and suddenly an apple fell on his head, and he was tried that why the apple fell down, it didn't go up. So from there he discovered the laws of gravitation, the universal laws of gravitation. So let's share my screen and let's start today's topic, that is gravitation, class 9, chapter 9. All right. So thank you so much for your love that you have showered on me. Please suggest me something. Most of the videos I will keep my comments on so that you can share your views in the comment box. And before going through this video, you can jump to the chapter wise and the class wise playlist in the YouTube channel called Bratati Science Class. I am MSc, DEd, CTET and GATE qualified. I used to be 13 years teaching experience in different CBSE schools across different states in India. And at present, I am completely taking online sessions for kids as well as for the adults. And taking public speaking expert class in Planet Spark. At the same time, I have created this channel keeping in mind about all those students who are not able to go regularly to school, and this 9, 10, 11, 12, a lot of time required for self study. I hope you can relate to this. I have kept my language in English because I want everyone to understand the language. I sometimes may use Hindi because I know Hindi, Bengali, and English. But when you are going to college, you are going to need all the books, all the materials in English. And if you're going outside, it's not that you are in your country only. So English is being an international language. I am not keeping it very hard. It's very simple words I'm using so that you can understand it easily. And I will be going slow. And today's class, we are going to discuss several things like, for example, we are going to talk about what is gravitation's universal law of gravitation, the free fall, the difference between mass and weight, the thrust and the pressure, their definition, what is buoyancy, the Archimedes principle related to this, the solves to the problem, and the exercise question answer. So let's begin with gravitation. Gravitation, that is in the whole universe, as I told you, in the whole universe, any two objects, they will attract each other. And keeping in mind, Newton's suggested that this force of attraction actually directly proportional to the mass of these two objects and inversely proportional to the distance between them. Inverse means opposite. So two objects, if they are closer, the attraction is more. But if they are far away, then the attraction is less. Okay, so it's proportional to the mass. Now that F is the force of attraction. This force is directly proportional to capital M and small m are two individual mass of the objects, and d is the distance between them. So let me write capital M and small m are mass of two different objects, and d is the distance between those two objects. Okay, so now second equation that comes from the laws, that is F varies as 1 upon d squared. because this is inversely proportional. If we combine this equation number 1 and 2, from there we get F varies as m into m by d square. M varies as m into m by d square. Now, any proportional, if we want to put an equals to sign, there comes the universal gravitational constant, which is represented by the capital G. And the value of the capital G is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Now, what to do, how to remember, and from where it is coming. 6.67 into 10 to the power minus 11, this value you can keep it in mind for problems, and this is universal constant. It won't change any if you go anywhere in the world, in the universe, it is not going to be changed. Sometimes this is approximately, we can even write 6.7 into 10 to the power minus 11 to make it simpler. And how do this unit come as Newton per meter square per kg square, that we are going to see here. So here G equals to, if we know this equation was F equals to G into capital M into small m by d square. Now with the mathematical expressions we need to find out the value of G. So this G will come this side. That means G equals to F into D square cross multiplication divided by M into M. Now F here equals to force, and we know the SI unit of force is Newton. Right. Then here we can write this is Newton, F is Newton, d square, d is the distance between these two objects, can be m equals to meter. Here this m is meter, and m both must be in kilogram, kg into kg. So from here we are coming to the solution that the unit of G is going to be Newton into meter square per kg square. This is the unit of G. So from here it is Newton into meter square by kg square. Clear? All right. Then importance, why this gravitational force is required in our day-to-day life. Do you think it's important? Yes, of course. There is the gravitational force. That's why we are able to walk on the ground. Even we jump up, we come down, right? Any item, if we throw, then obviously any item, if we throw, that will come down. It won't go up above without any limitation. That cannot be possible. And there are rainfall. The rain falls down, the snow falls down. Okay, these are also due to the reason of gravitation. The tidal force, we know the tide happens due to the attraction force of the sun and the moon together. So this is also one of the reason or effect of gravitational force. These planets are moving in the solar system around the sun, and the satellites, including our own satellite moon, is revolving around the planets. That is also due to the gravitational force. So this is important. Now we are moving to acceleration due to gravity. So here the second G, that now we are moving to the small g. The small g is acceleration due to gravity. Any object, when any object, okay, small g, which is the acceleration due to the gravity, when any object is free falling. Suppose I'm holding an object and I just lift it, so it will come down to my hand. Okay, it will come down, rather I'm not applying any other force to it, I just drop it down. Sometimes we just throw it. We throw it means we are pushing an object, we are applying a force. But in this free fall there is no force applied, I just leave the object, it will come down. There we are ignoring the air resistance. That means we call the objects are free falling. As the objects are free falling, there we can see the acceleration is only due to the gravitational force, the force by which the earth is attracting any object towards it. Okay, so now let's move to, see this one. This is acceleration due to gravity. The acceleration due to gravity, which is the change in the velocity by time. This is the acceleration. So acceleration is change in velocity with the respect to time. That means change in velocity we can write as a del V. Del V or V minus U. Final velocity minus initial velocity, that is del V. So we can write here del V equals to final velocity minus the initial velocity. That is the change in the velocity with respect to time. So this is A. And we know again F equals to m into A, where m is the mass of an object and A is the acceleration. Okay, so in this case, we know this is another equation from we learned that F, the force equals to mass into acceleration. And here G is the acceleration due to the gravity. Now, accordingly, we can make these two equal. That means A is del V by T and this A can be replaced by G, that is the acceleration due to gravity. Then these two equations we know. The first equation is the force equals to universal gravitational constant capital G into the two mass of the object. All right. So we were comparing these two equations, that is, one equation is F equals to universal constant into capital M into small m by d square. Another equation F equals to mass into acceleration. So when we know the F equals to this both are equal, then why don't we compare these two? If we compare this two, m into A equals to g into mm by d square, from there we can get the equation for the acceleration. This acceleration is equals to capital G, that is universal gravitational constant, into the capital M by this square. Now why we are taking only M, because this M and this M we can cross both sides, right? Then only capital M or mass of one object is there. This A can be replaced by G, that is the acceleration due to gravity, which will be equals to capital G into m by r square. Are you able to get my point? These two equations are both equals to F. Now we are comparing these two. So if we compare these two, 1 and 2, we get this equation, that is m into A equals to g into mm by d square, and from that we can cross this 2m and we get finally this. This g is replacing A and we get, that is universal gravitational constant into capital M. Capital M can be the mass of the object that is coming down to the ground and r is the radius of the earth. Okay, so G equals to capital G universal constant into mass of the object which is free falling in by, that is the radius of the earth, and we are considering it in any place that is near to the surface of the earth. If it is in a height h, then we have different formula. If it is coming depth towards the center of the earth, we have different formula for that. So now see the value of G on the surface of earth, as I told you. So this we know the value of G is F, the capital G, that is the universal constant, into the m. This m can be the mass of the earth, the mass of the earth, and the radius of the earth is r into square. So if we know this is the small g, now we are putting the value of capital G as 6.7 10 to the power minus 11. The unit is Newton meter square per kg square down, and 6 here 6 into 10 to the power 24, which is the mass of, this is the mass of earth. Okay, we are considering the body, the object, as one unit object, unit mass object, then mass of earth, and this is the radius of earth. This is the radius of earth. Okay, then we will get this value as 6.7 into 6, then 10 to the power minus 11 into 10 to the power 24 upon 6.4 10 to the power 6 into 6.4 10 to the power 6, because it is a square root, because this is a whole square, so we wrote 2 times. So if we solve it, finally we are getting approximately 9.8 meter per second square, and this we consider as the value of g. So remember, small g on average, the value we take it for solve for any problem is 9.8 per second square. Okay, and this is the one we consider as the average value of acceleration due to gravity. As I said you, if we are moving from the earth's surface to the above with the height h, based on that the g will change, because the earth is not a total circle, it's not a complete circle, rather it's have an elliptical shape. Do you agree? So if this is the shape of the earth, now we know this is the equator and these are the pole. See, the radius at the equator is obviously more than that of the pole. Okay, the radius is more than the pole. So here we are writing our equator is greater than our polar. Do you agree with me? And now we know if the r is in the inversely proportional to the g, then if r is more, the g is going to be smaller. If g is going to be smaller, we know the weight depend on the mass and the accelerations, that is the w equals to the force by which the earth attracts any objects, that is the weight. Okay, so it is clear that the g is not same or fixed, but it changes due to the shape, due to the altitude, or even the depth of the object from the surface of the earth. So as the altitude increase, if the altitude, that is the height increase, it is inversely proportional to g, the g will decrease, right? So here comes the formula of the small g, which is acceleration due to gravity at the height h. Okay, this is the height from the earth's surface at this height. Suppose if it is, say that an object is 10-meter height from the surface of the earth and it's falling down, then calculate any other thing, like calculate what will be the acceleration due to the gravity. You can find out small g h equals to g of 1 minus 2h by r. Here r is the radius of the earth and h is the height to which the distance traveled. So this one we are considering when the object is at a height h from the surface. Now, considering the depth, when the object is moving down towards the center of the earth, then the g decrease. And how we will calculate that? G, the acceleration due to gravity at the acceleration due to gravity at the depth d, that is going to be g into 1 minus d by r. So this d is the depth from again the surface of the earth, and capital R is the radius of the earth. These formulas we have to by heart. Now how these formulas are coming, this is a huge mathematical calculations which is not required for this class. We can derive it when we are going to higher classes. Now, so universal gravitational constant is the capital G, and acceleration due to the gravity, that is the small g. Is there anything to confuse between this capital and the small g? Nothing. Capital G, as it is the capital, it is constant. Remember, it never changes wherever you go, wherever we can keep any object. So it is always constant. Its value is also constant, which is 6.7 into 10 to the power minus 11 Newton meter square per kg square. Now, why it is required? It is required for we are bound to the earth, we are moving, we are walking, and tidal waves, the planets are moving, the satellites are moving, so on. Okay, then why acceleration due to gravity is needed? It changes wherever the object is in the surface or in the pole or at the equator, it changes its value. but we consider one average value for small g, which is 9.8 into 10 to, 9.8 meter per second square. This is the value we consider, and it changes with the radius, or we can call at least this is changes with the distance between the object with the earth. Okay. Now, what is mass? We are talking everything of mass. Anything, any component that is made up of some matter. Okay. Some matter is present in this material. So that is called its mass. We know mass never changes, right? Mass is constant wherever we are in moon, in the universe, in space, in the earth, wherever we go for any particular component, the mass is fixed. And the unit for the SI unit will be kilogram, and the SHS will be gram. Now coming to the weight, it's actually a force by which earth is attracting any object towards it. So that is the weight, and it changes, it varies from place to place depending on the height at which the object is, isn't it? Like we are here in moon, in earth, so whatever our weight is, like for example I am 50 kilo, or 50 kilogram is my weight. So at 50 kilogram force we are being attracted or pulled by the earth. Okay. Now it changes. The SI unit will be the same as the unit of the force, which is Newton, and the CGS unit is dyne. And here we know 1 Newton equals to 10 to the power 5 dyne. Now, as we already discussed, so mass and weight is clear to us. The weight can vary, but the mass won't change. And the weight of me, of anybody here in 50 kilogram, then if we go to moon, then it is 1/6 of the attraction by the moon compared to the earth. So we will be weighing there 6 times less whatever we are weighing in the earth. Not for us, it's any object. If we bring them there, their weight is going to be 6 times less than that of the earth. Now, free fall, already I told, when the object is falling down without influence of any other resistance or any other force. Now, three questions. Now, why we are talking so simple, making it just, I will tell you, we are talking about the revision. So, my classes generally I've explained, but in keeping in mind that how to revise in the short time. Now, the three questions that are very important for solving the sums or problem solving of taking free fall equation, keeping in mind the acceleration should be constant. If the acceleration is constant, then only we can apply these three equations. So number one, v, that is the final velocity, equals to the initial velocity plus acceleration into time. So the first equation comes as v equals to u plus at, where a is the acceleration at t time and u is the initial velocity. Now, second equation for the displacement of the object from time in time t, it is ut plus half at square. Now, don't tell me, ma'am, why it is capital V, it's capital U, it's capital S. It's nothing like that. It's simply I was typing. So you can take it as small v, is same as small v, it is same as small u, it is same as small s. So there is no the capital letter and small. Here, small v equals to u plus at, and s is ut plus half at square. Okay, all right. So v square equals to v square equals to u square plus 2as, or v square minus u square equals to 2as. That is the third equation, where as is the displacement at time t, and here if we replace a with g, and as is the displacement with height h. So as displacement is same as h, I am writing, and a acceleration is same as small g, that is acceleration due to gravity. Then these three equations we can use to find out any of this value. If the two are given, we can find the third value. If the initial and final velocity and time is given, we can find the acceleration due to gravity. If the initial final velocity, acceleration and time is given, we can find out the displacement. Okay. So like this, we can find out any of the We will solve the problem at the end of the lesson. So please wait and watch the video till end. Thrust. Now it's a new word for us, thrust and pressure. So thrust is the perpendicular force acting on an object. Okay, so this is my pen, and when I am holding it perpendicular to my hand, it is called thrust, the perpendicular force. And pressure is unit area, the thrust on unit area, that is the pressure. Now see here I am giving it the perpendicular, and even here also I am pressing it perpendicular. So both are perpendicular, but here the point of area is small, so the pressure will be more. And here the point of contact is more, so the pressure will be less. Now what is that? Both were perpendicular, then because the pressure is thrust per in unit area. Now see this, it is thrust per area. If the area is small, then the thrust or the force is more. Now if the area is bigger, as you see, this is the inversely proportional. So pressure, from here we can tell the pressure is universally proportional to the area of contact. If the area is small, point of contact is small, the pressure is more, and the point of contact is more, the pressure is less. Now I hope it's clear. Now, with this, I can give some real life example. For example, like camels are walking in the desert, or even we are walking on the sand. Then we are putting our feet, okay, and we are putting our whole pressure, the whole body pressure onto it, and we are walking. We feel difficulty on sand, obviously, but still we can. Now, if we want to sleep, we our the whole body, the point of contact is more, so the pressure is coming less, so it's not that we are getting sink into the sand, not possible. But our feet goes deep inside the sand. Is it true? So that is the reason. Again, if I'm taking a nail and I have to stuck it into the with the hammer, I'm just pushing it into the wall, so that I have to put this. So the point of contact is again the small, so the pressure is more. Instead of doing like this, when the area of contact is more. Now, effect of pressure, you know what is fluid? The fluid are the liquid plus gases. Okay, the fluids are liquid plus gases, whatever present in our surrounding, that is called fluid. They do not have a specific or definite shape and size. Wherever they go, they occupy that particular space or of that shape of that container, right? So the pressure exerted by fluid, if in a glass I take some water, or in a bottle I take some water, the bottle is full, so it is the fluid or the water or any liquid present in that container is exerting pressure in all the wall, all the sides along with the base of the container. And as I said, it's directed all the way along with the base. So the pressure is coming as the force or the thrust. Here the perpendicular force is the thrust per area, or this force sometimes we call it the weight per area. So, as by giving the example of a tank or a bottle filled with the water, if I put hole in the same depth, suppose at the middle part of the bottle, so there the pressure is same. The pressure at the particular point remains the same, because it only depends on the depth or height from the surface of the liquid. It doesn't depend on the size and shape of a container. If I take a cup, a mug, a bottle and tub, a bucket, at the same distance from the top, I have put a hole in it, right? Then if we put a hole in it, then the pressure remains same, because it depends on the depth or the height. Got it? All right. So here, it doesn't depend on the size and shape of the container. Now, P equals to rho into G into H. The rho is the density, the G is the gravity, and H is the height or depth from the free surface of the fluid. Right? So, remember P equals to rho into G into H, where rho is the density, G is the gravity, and H is height from the free surface. Okay. So weight of an object on moon, that I told you already, it is 1/6 of what is there in the earth. So if we have to calculate the weight of any object in the moon, that is again universal constant g will come, and you remember the formula, g into capital M into small m by d square or r square. Here the radius of the moon is 1.7 into 10 to the power 6, and for earth it is 6.4 into 10 to the power 6, the radius of the earth, and the mass of the earth is 5.9 into 10 to the power 24. So if we compare Wm, that is the weight in the moon, upon weight in the weight of an object in the earth, then it is just come as 1 upon 6. You are allowed to use the calculator. So this kind of derivations you can simply put it in the calculator. But for easy calculations, what we need to do, whenever there is a square, we need to break it. Okay, and that will be easier. For example, 7.4 into 10 to the power 12 upon 1.7 into 1.7 into 10 to the power 6 into 10 to the power 6. So I wrote it twice because it's a square. So I'm solving this derivation. So 7.4 into 10 to the power 12 into 10 to the power uh, 10. We can write like this because 22 equals to 12 plus 10, right? And down, we need to calculate 1.7 and 1.7 together. So that we will do in the calculator. And here we get 10 to the power 12. So this 2 will go. And you see, we can omit this 2 point also. And for this, if we want to remove, this point will go above in the form of 10 to the power 11. Okay, so this is 1. It comes like 74 into 10 to the power 11 by 1, 17 into 1, 17 into 17. So if you solve this, you got 1. And from earth also we will get like this a formula. And if we do Wm, whatever this is Wm and this is We, if we compare these two, we will get 1 upon 6. So from there we come to know whatever weight of any object in the earth, it is just 1/6 in that in the moon. Okay, now coming to the new term, that is buoyancy. The buoyancy is the ability or the tendency of any object to float in a liquid or fluid or water, whatever you say. So the ability or the tendency. So you remember the famous Archimedes story. The Archimedes was not able to find out that how much in golden king's crown, how much extra material was added to it, the neat gold, and what is the extra material, or what we call it, the rough items is added to it. Okay, so that was the question from the king, that you need to find out that how much mixture or how much the ingredients which are not required, no, other than gold, is mixed with the crown. So he was not able to find out how to get it. Then once he find out that how to get it, that if any object it is being dropped. Okay, now see, my mouse is there, and if I take a bottle of water and if I throw this, it may be submerged. It's not floating and it doesn't no sink, but it is submerged. So it depends on, again, the buoyancy. The ability of any object to float in a fluid is called its buoyancy. So laws of flotation is the liquid or the object that have a density, and the fluid also have a density. So if the density of, here d equals to, we are talking about density. Okay, so here the OD is the object density. If the object density is less than the liquid density, sorry, this is D, this is LD. Okay, so if the OD, the object density, is less than the liquid density, then the object will float on the fluid. And the object density, if it is equal to the liquid density, the object will submerge. I mean, it will be in the middle of the water, and neither it floats, neither it sinks. It will be in the middle, it's submerged. Okay, floats means if I keep a paper boat, that is called floating. Okay, if I have something like submerged, submerged means half of the part, suppose the boat, the ships, and any kind of water vehicles, there some part is inside the water, some part is above the water. So those kind of object we call it submerged in the water. And if the density of the object is greater than the density of the fluid, then obviously the object will sink down. So Archimedes was taking the bath in the bathtub. He jumped into the tub and equal weight of his came out, of water came out. So he just ran Eureka and started running on the road. We know this story, almost everybody. So this is the story behind the Archimedes principle. He said and he discovered, Eureka means I got it. I got it. Finally, I got it. So he was trying to find out that how to find out the net gold and what is the inappropriate material or the mixture mixed with this. So that is when a body is partially or completely immersed into a fluid, it experienced an upward force. That means the body is posing one downward force. This can be the gravitational pull. The same rise, Newton's told every action will have an equal and opposite reaction. So for that, there is a reaction force, that is the upward force, and that is equal to the weight of the object, the equal amount of weight of the object. So fluid will be displaced by it. Is it clear now? So if I have this one, I am dropping it into the liquid. That equal amount of weight of this object will come out from this tub or from the liquid. This is the Archimedes principle. Now we have this NCERT book. In this book we have the problem solving. So we are into the 102 page number and 9.1 sum. You can see here the question is given, the mass of earth is given, the moon, the mass of moon is also given, the distance between the earth and moon is shared. So G is given. We need to find the force. Just we have to put it into the formula. So we know F equals to G mm by d square. So when we know all the values, we just have to put the values. We will get the answer. So G is given 6.7 for mathematical solve, 10 to the power minus 11. And this units, if you put finally, this is a weight and the force. They are asking the force. So obviously it is Newton, SI unit. This is how we can get the answer. Okay. So again, as I told you, when there is 24, 22, minus 11 and square, d square means this will be 10 to the power 5 into 10 to the power 5, that is 10 to the power 10. And there we get the earth and the moon. So those 10 to the power term we have to keep it for crossing, and then we can derive to the sum. Now page number 104, number 9.3, read the question. Here it is given, an object is thrown vertically upwards and rises to a height of 10 meter. So when we throw an object upwards, up to a certain height it moves and then it becomes stationary there for a fraction of a second. But the final velocity is 0. Initial velocity need to calculate. So they are asking the initial velocity and also the time taken by the object to reach to that height. So here v is 0, the height is 10 meter, find the initial velocity and the time taken. Small g, acceleration of gravity will be in consideration, which is 9.8 per second, 9.8 meter per second square. So A is reverse or negative because it is going upwards. So remember, if g is negative, when an object goes upward, when an object goes upward direction, and this is positive when the object goes downward direction. Clear? So as it is going upward, so we will consider minus 9.8 meter per second square. We need to calculate u. Okay, so v square minus u square equals to 2as. We know this is 0 and u need to find out. 2 into this one minus 9.8 and as is the displacement, that is 10. So from here we can get it 2 into 98 and this 2 minus we can cross. So u equals to root over of 2 into 98 we can find the U value. And if we know U we know V, we know A, we know, we need to get the T. So this is the formula, V minus U by A. So put the formula and we'll get T. I'm not deriving it, it's just the use of the calculator. You're allowed to do this. You have to solve in this way. Now page number 106 if you go, question number 9.4. There you see, mass of an object is given as 10 kg. What is the weight of the earth? Here small m is 10 kg. What is the weight of the same object in the earth? So mass is given and we know weight is again a force by which that object is being attracted equals to m into g. M is given, g is this. As it's coming down, I said it's a positive. If it goes up, then it's a negative. So it is 98 Newton because Newton equals to kg meter per second. 9.5 is saying the object weighs 10 Newton when measured on the earth. What would be its weight on the moon? So we know it's just 1/6. So we have to divide and get it, the answer. Now we are moving to exercise. In exercise, we have some questions. Today we are going to solve till 10, I think. Let's see. The first one, how does the force, how does the force of gravitation between two objects change when the distance between them is reduced to half? So d is now d by 2. It's becoming half and we know it is inversely proportional. So there is the square. So the 4 to this was my f. So f1 will be actually, f1 is 4 into f. So this is 4 times than before. Second one, the gravitational force acts on all objects in proportion to their mass. Why then the heavy objects does not fall faster than the lighter objects? Because it doesn't wait on the, acceleration due to gravity is this one, all around the surface. So it is same, right? And the mass of the object is same. Okay, heavy object, light object, in the sense the attraction, the force of attraction is more, isn't it? So here the hence g is constant. So acceleration due to gravity is constant. Therefore, the free falling, that doesn't depend on their mass. It depends on the g. So as g is same, so the object will fall at the same time. Now, next one, they are talking about number 3, the magnitude of the gravitational force between Earth and 1 kilo object. Remember, small m is 1 kilo, capital M is the mass of the Earth. Mass of the Earth is given, radius is also given. They are asking that what is the force of attraction. So we know F equals to g mm by d square. Here small m equals to 1, they said, 1 kg. So g is given, m mass of the earth is given, and the distance also given. We have to just put and solve it. Number 4, the earth and moon are attracted to each other by the gravitational force, right? Does the earth attract the moon with the force greater or smaller or same as the force by which moon attracts the earth, and why? We know that again the mass of the earth is more, so the earth does not come towards the moon as it's now the fourth one, the earth and moon attract each other with the same force which is opposite in direction. Why? Because we know the g into the f equals to again g into m into small m by d square. Here this m and m are all fixed. So as these are all fixed, so the same force but the direction is opposite to each other. Fifth one, if the moon attracts the earth, why does the earth not move towards the moon? Why? Number 1 is inertia. The mass of the earth is more, so the inertia is more. And that is the reason that mass is heavier, so the earth won't be going towards the moon. Sixth one, what happens to the force between two objects if the mass of one object is doubled? So as the force is proportional to the mass, so the force also is going to be double. Number 2, if the distance between the object is doubled, if the distance is doubled as it is inversely proportional, the force will be 4 times less, twice and 4 times less. And if the distance is thrice, then the force is 9 times less. And if mass of both the objects are doubled, then both the objects are doubled, So 1 doubled, so it was twice. So both are doubled, so it will be 4 times more. Then the force is going to be 4 times more. All right. Then seventh one is said, what is the importance of universal law of gravitations? We already know the rainfall, snowfall, tidal effects, the movement of the planets, movements of satellites, we are bound to Earth. These are all happening due to the presence of universal law of gravitation. Eighth one, what is the acceleration of free fall? As we told you that when there is no air resistance, excluding the air resistance, the free fall is just we leave any object and automatically it will fall on the ground. Only the gravity or the gravitational force is acting on it. That is denoted by small g. Ninth one, what do we call the gravitational force between the earth and an object? We call it weight. So weight is it is the weight which is the gravitational force between the earth and the object. Then Amit buys few grams of gold at the poles, but he is handing over the same at the equator. Remember, as the elliptical shape of the earth, the radius of the pole, okay, the distance is less compared to the distance of radius in the equator. So the weight will vary from the pole to the equator. The pole of the weight of the gold will vary because it depends on the distance and mass. Distance change, so the weight also will change. 11th one, why will a sheet of paper fall slower than that of the crumpled into a ball? So when we throw a piece of paper or when we crumbled it down, which will fall slower? The sheet of paper will fall slower because the more surface area, the point of contact is more, the pressure is less, so it will fall slowly compared to the crumpled paper which is crushed into to make a ball whose point of contact is small, so the pressure is more, right? Now, 12th one, gravitational force on surface of the moon is only 1/6 of the earth. So what is the weight in newtons of a 10 kg object on the moon and the earth? So the 10 kg object, they said the mass is 10 and this is 9.8, right? The acceleration due to gravity. So weight in the weight in earth is m into g, which is equals to 98 newton. And in moon we have to divide by 6. We will get the answer. 13th one, the initial velocity is given. A ball is thrown vertically upwards with a velocity of 49 meter per second. This is 49 u. So as it goes upwards, the v is going to be 0. Calculate the maximum height to which it rises. We know a is equals to v square minus u square by 2a. A is given, it's minus because it's going upwards. So we need to calculate the s. And total time taken. So total time taken, again a is equals to ut plus half a t square. So from these equations we can get the time. So what is the time we can find out from here? I think it is still this. Hope you have understood and you enjoyed the sessions. If you like any part of the video, kindly motivate me by pressing the bell icon to get the all notification. Subscribe the channel if till it is not done and share with your near and dear ones, and also hit the like button if you like any part of the video. So see you next time. Till then, take care, stay healthy, happy learning to you all.